And he is chairing the session. So he is the chairperson of today's session. So welcome you, sir, once again in this today's session.
Thank
And
you, Prof.
being as president of Nexus University, South Africa, welcome you in this program, Mr. President. And today's lecture, today's invited talk is from Professor D.K. Lobiyal, sir, from JNU, Jawaharlal Nehru University, Delhi. So I welcome you, sir, in this program. Professor Lobiyal, sir, is a teacher of my teacher. So thank you so much, sir, for accepting our invitation and joining in this program. We will be blessed with your lecture as usual, sir. Thank you so much, sir. And moving forward, now I will invite to Professor Atul Gaur, sir, University of Delhi, to formal welcome of today's speaker, Professor D.K. Lobiyal, sir. Over to you, Atul Gaur, sir.
Welcome, Professor Lobiyal, sir. The speaker of this session is Professor Daya Krishna Lobiyal from School of Computer Science and System Sciences, JNU Delhi. Professor Lobiyal obtained his PhD in Computer Science in 1996 and MTech in Computer Science in 1991 from JNU. Professor Lobiyal has been engaged in teaching and research in JNU for last 26 years. He has been supervised 44 PhD students and more than 50 MTech students. Uh, his research area includes wireless network, natural language processing, and computational neurosciences. He has authored more than 125 research articles in various international journals, including IEEE, ACM, Elsevier, Wiley, and Springer, etc. He has delivered more than 100 talks in various national international conferences in India and abroad. Besides academics, Professor Lobiyal has been involved in various administrative duties as well. He has held position of Direct IQAC, Chief Warden, Placement Cell of JNU from 2013 to 2015. He served as Hostel Warden, JNU for around 17 years. Professor Lobiyal served as 4 times elected president of JNU Teachers Association. At present, he is serving as president of Federation of Central University Teachers Association. He is also senior member of IEEE Society, ACM, fellow of IETE India. Sir, the list of your academic achievements is endless, but the audience here is eagerly waiting to hear you. So I kindly request you to enlighten us with your vast knowledge. Professor Lobiyal, sir.
I don't know the kind of group of the participants. I don't know much about. Maybe at least group from various places, computer mathematics.
Professor Lobiyal, sir, kindly increase the volume of your system. I don't.
Come on. Let's now it is all right.
Uh, Professor Deep Singh, but I mean your voice is not coming very clear to us. Professor Deep Singh, kindly confirm. Is it problem with my end or everyone else?
I'll remove my. Now it is audible.
Yeah, very much audible, sir. All right.
This is somewhere some problem with the Zoom with my system. Am I audible now?
Yes, sir. Yes, sir. Very much audible. Please continue.
आपकी कम आ रही है आवाज पता नहीं है मेरा. Just wait.
Oh, okay.
Now it is all right. Now am I audible clearly?
Yes, sir. Yes, sir.
See, my system has some problem with Zoom, it seems now. Otherwise, in Google, it runs fine. Google Meet. Anyway, see my topic. Shall I start straight away or?
Please start, sir.
Okay. Deep, your voice is not audible. Deep sync in यारी मेरे पास. But anyway, let's share my screen. My topic is a little different. What is shown there then is what I will talk about. So my slides are visible?
Yes, sir.
Okay. Let me start with this topic. Because I have been talking on this topic for a longer period of time on machine learning for natural language processing. And so it consists of two parts basically. One is how I see the machine learning. I'll give a different kind of flavor a little bit, and then its application to machine learning, because machine learning, it's NLP, because NLP is one of the areas of recent applications where large scale neural networks are being applied for machine translation, what you call neural machine translation. And therefore it becomes one of the very important area, because as Google, Microsoft, everybody has been trying to translate across multiple languages. I mean, it translates also, but there are still problems. And also, if you look at the language itself, it's a big data. So I thought this could be a region that it could be a justifiable topic, but whatever way the audience take, let me start with. See, if you look at, because the participants might have heard many lectures on machine learning, so I'll not go that what machine learning is. It is supervised, unsupervised, semi-supervised. You might have heard a lot about that. So my focus is not on that. So how I see is machine learning to me is completely, it is an optimization problem where you try to get the optimal value of the parameters of a model. That's what I fundamentally see. You might be hearing gradient descent method and so and so. So why can't there be other optimization methods to solve this optimal value of the parameters of the model? And I'll explain what does it mean then. But the first question comes before I try to apply an optimization problem to solve the optimal value of the parameters, but the question of the model. But how do you get the model? That's the fundamental issue. If you have a model, then you have a data, then you try to train, and then train means what? Getting the optimized value of the parameter. That's next question. So, but how to get the model? That is one question. And the second question is how to get an optimized model. If it is, then how to get the optimal value? That is the second question. Now, one important question which everybody should keep in mind is that the model may be decided by the discussion with the expert and analysis of the data. This is very important. Which model I should use? Many times, okay, I use this model, that model. Why? Because it was being used in the literature, so I picked it up. So somebody used it, I tried other models. That's how we go. So general researchers try to see in the literature, and whatever model they have used this, I'll use this. But the question is, you must also have certain idea of how to use a model, right? That's what the whole lecture will be all around. Then I'll go to further. Now, the moment we talk of model selection, before I talk of model selection, anyway, see, let me put it in a very plain way. If you have I'm not talking new thing, but it is very common, but let me put in different perspective. That's the way I try to do. If you have a set of cars and you are asked to select in two classes, say for example, whether a car is a family car or not a family car. Family car, how do you define a family car? Itself is a big issue. But when you say knowledge extraction, then you have to see that how people see what should be a family car. At least say 4 people must sit, 2 parents, 2 children, and it should be comfortable, say for example. And that's one part. And then output will give whether some car is a family car or not. positive is family car, negative is not a family car. You may feel that I'm talking a very trivial thing, but wait for a minute. So how do I put it? See, it must be within the affordable region, affordable prices, and also the engine power. Two factors if I take. X1 is the price of the car, X2 is the engine power. So based on that, I decide whether some car is a family car or not. So generally, car has 4-seater cars. We focus on that. But let us, for understanding two parameters, X1, X2. It is very high costly, then everybody cannot afford. So that way we design that engine power. Now, the moment we say this, so before selecting a model, what do you say? That a car, to be a family car, its price and engine power should be in certain range. That's how we decide. So that means the price must be between P1 and P2 value. And the engine power should be power E1 and E2. So that means you have certain range you have decided for these two values, parameters of it. Now, if it is within that limit, then you say it is a family car. If it is outside that range, then you say it's not a family car. Now, how do you select that? So then you have to get a suitable value of P1, P2, E1, and E2. And let me try to see that if I represent this by rectangle, and then the rectangle will form a class. I'll show you. So any car with, see, if you look at this diagram. So on the x-axis, I have P1, P2, and y-axis, I have E1 and E2. And what do you see here is that any car falling between P1 and P2 and E1, E2, and this forms a rectangle, say. That blue rectangle may be visible. So anything within this blue rectangle, I say it is a family car. If it is outside that, I will say it is not a family car. It's very simple, right? So that is why the range is important. So my model is a rectangle, equation of a rectangle. And what is the equation of a rectangle? If you get two coordinates like of this line and other lines are parallel, probably this is a rectangle. I get this coordinate and then this coordinate and this coordinate, fine, or all four coordinates, then you form a rectangle. So my model will be represented in terms of a four lines, or that's, so I need simple line equations which form a rectangle. Why can't I have a circle here now? If I make a circle here, it could have been a circle also. The all positive points could have been covered by a smaller circle also. Then now you have, whether you choose a circle, you choose a rectangle. That's what I'm trying to say. What do you call a, say, for example, model selection? When you are defining a model, whether you should select a circle as an equation to represent this case, or you should select a rectangle to represent this case. You have both the choices. Now, that's where initially when you make a choice, either you may have some data analysis of the data and what pattern it follows, then probably you can decide it. But many a times, the data points may not be in such fashion that initial analysis you can try to find some equation for that which exactly matches that. We don't know. That's the issue. So you have multiple choices. You may have a bigger polynomial. Why only a polynomial degree all this rectangle? It may be something else. A polynomial with degree 5 may represent data sets points by much better way. So you will never know which equation will fit into that. That's what we are saying. Now, so how do you assume that this is the correct rectangle? Now the question is, if I assume that you have a large set of data, you don't know what equation will fit into that, right? So now the question is, how do you assume that this, if I select this rectangle, I don't know whether this fits or not. यहाँ तो कम डेटा पॉइंट आपको साफ दिख रहे हैं, आपने हमने ड्रॉ कर दिया, बट अगर मैं खाली आपको डेटा पॉइंट बड़े बड़े दे दूं तो आपको पता लगेगा कि रेक्टेंगल होगा और ये फिट करेक्ट होगा. That's what we are talking. So now, even you take this, some values may be outside and some may. Now, therefore, what happens is there is a possibility of many rectangles. If you look at this, why I may have a more closer rectangle also, right? And it may be little larger also, Maybe here not a possible because this will come inside, or it can be here rectangle. So if you look at within this rectangle, till all 5 positive points are covered, there is a possibility of multiple rectangles. And the closest one may be the optimal rectangle. If say it may be in some cases, may not be the, because I may need some margin for error. I may not take the closest one. Because if little bit the deviation of a point will give a wrong result. So I may not take a closest rectangle. So if you look at, if I assume, so there were multiple rectangles possible. That's what I'm saying. So which rectangle you choose out of that? Right? So if you look at this way, hello. So what we call is therefore the equation. Hello.
Participant, please unmute yourself. Please mute yourself.
Okay.
Professor Lobiyal, please continue.
Yeah. So I thought somebody may have some queries. That's what. Anyway. Therefore, the point what we are trying to say is this equation of rectangles may be multiple possible rectangles depending on the value of the points, which you call the parameters P1, P2, E1 parameters for us now. And they may take multiple values, therefore the rectangle may change. So therefore, I have a class of rectangles, right? And that's what we call it is a hypothesis class or a hypothesis function H. That means I'll explain gradually in units. So that means I have assumed a model which have possible classes. So if I say the model is a rectangle, there are multiple possible rectangles which may represent this, fit into for this data. So that means I am assuming, whether you assume a rectangle, you assume a circle, or you assume a polynomial, that's what you have to assume in the beginning, and therefore it depends on the expert knowledge, right? Which model will fit the data, because the experience as well as sometimes the data analysis will help you to decide, to hypothesize which model will fit into that. That's the question of model selection comes. So that's what I say. Based on the knowledge of the expert and the data, we assume the hypothesis function, what will fit in that. And nobody can tell you that you take data fit that one. So through the help of the examples, you learn now we learn the value of P1, P2. If once you decide that it is a rectangle, then we have to select the value of P1, P2, and E1. And therefore, we need to optimize from the training data and see that what is the optimal value of P1, P2, E1, and E2. So that's what training means. Many times you ask questions from the student, what is training in the machine? Training means you are getting the optimal value of the parameters of the model. That's what the training does, right? So this is how you have to look at it now. So by learning the parameter value, we find a model. If we have find the optimal value, that's it. We said this is the model which will be used, and this is the model we have determined. Now this model will be used for prediction or classification or whatever you. So what you find is by optimal value of this in a class of H, if you have multiple rectangles, H is a class of rectangles. I found a particular rectangle where the value of P1, P2, E1, E2 are optimal value. That is called H, small h. So small h is one of the function or one of the equation in a set of equations of capital H. That's what we are saying. This is all, but we don't know many things. I'll explain in great detail as I'm trying to build up. So these optimal values will not be exact values of the model. Why? That you have to understand why it is not exact, because we don't know the exact model. Why? Because we don't know what function exactly fit into the data. Had we been knowing that कि कौन सा function इसमें fit होता, तो हमें इतना कवायद नहीं करनी. We don't need to train and do everything because we don't know what function will exactly fit into the data. We don't know that. That's what all the training and everything is there. So what we are trying to basically do is assume that there is a function fx which fits to the data and which you don't know. This is the whole issue, अगर कोई डेटा पॉइंट्स है कुछ तो उसमें फिट करेगा, maybe a degree of polynomial, very high degree, or some other equation, whatsoever fits, maybe a differential equation if you go on continuous this, some function will fit, the data will fit to the data. But the problem is you don't know that function fx, and that function you observe is fx, but we don't know that. That's what we are doing model. So therefore, what you try to do it, you are trying to start with the function h, and which you assume that this h is an approximation of f. So hx, which I assume, and that's what's a hypothesized function, which you initially think of, this will fit into. And there may be an exact function which fits to the data we don't know. So therefore, hx will be an approximation of fx. That's what whole the process of machine learning is. And the moment we say that, we can say that these values represent the model. Here the P1, P2 represents the model as per the hypothesis. So now the 2 points are very clear now. We are trying to fit a function of hx, and which may not the exact function, because we don't know the exact function fx. Therefore, hx will be an approximation of fx. That you have to keep in mind. Now, as I said, the expert defines the hypothesis class that decides the hx. The value of the parameters are not known, though we choose h, but we do not know which particular h is closer to class. Now, as which rectangle will fit into that. So, but once we restrict ourselves to the hypothesis function, we say that we assume that this is class h. We have to select one of the h. That means once you decide that we'll use a rectangle, then you have to select which rectangle. So therefore, what you call is that learning the class reduces to easier problem of finding 4 parameters that define h. So in this case, learning means what? When you say machine learning, what you are learning? So learning means you are trying to find the value of the 4 parameters, in this case P1, P2, even E2, for the value of for the function h. So if you assume something else, if you have a linear regression equation, if we say y equal to a1 x1 plus a2 x2 and so forth, so that means you are trying to find a value of a1, or generally you say w0 plus w1 x1 plus w2 x2. So you are trying to find the value of w0, w1, w2, and wn. So you assume a linear equation in multiple variables and then trying to find the coefficient which are parameters in that case. So you assume that model, simple linear model, because non-linear models become more complex. So learning means you are getting the optimal value of the parameter, and that is what you do in training. So anytime anybody say what is learning there, learning is this. Now, as I said, we do not know the real class or real function fx, which represents the exact class, but we cannot evaluate how. Now, the important point here is we cannot evaluate how well hx matches fx, because you don't know fx, right? And how good hx is an approximation of fx. How to evaluate that? That's what the whole problem is. Now, have we been knowing fx, then we could have said how closer we could have find the difference between and say that this is this much close, but we don't know fx. So what we have is now we have a small subset of data now. What is available with you? hx you have assumed. You have a given data set, data points. fx you don't know. So what you are doing in the training, with this small set of data, you are trying to see that how well hx approximates fx through the data points. That's what we do in the training. So training means we are trying to see that how well hx approximates fx through the data points. That you have to keep in mind, right? So we don't have all possible. Why it is so? Because you don't have all possible data. Had you have all possible data, probably you could have a better approximation. But that is not a possibility. Why? Because you take a sample also. That will come little later. So what happens is, therefore, there is error in hx. Because you don't know fx. How to evaluate that? That's what the whole problem is. Now, have we been knowing fx, then we could have said how closer we could have find the difference between and say that this is this much close, but we don't know fx. So Why? Because hx is an approximation of fx. Therefore, there is a difference between hx and fx. And that is called an error, which is called empirical error. Why empirical error? Because we are trying to approximate through the data sets, not the function. Through the data, by training, we are trying to approximate, and therefore there will be error. And then we call this error, we call empirical error. That you have to keep. So the difference between fx and hx, we call it. Now, so if you look at this, the error of hypothesis as given the training set x is given as. Now look at this. You find many times that you square the error. Fx minus hx whole square. If I sum on all points, that gives me the error. Right? So we will select an h for which what we try to do is we will try to find what we are trying to select from the data is. Now we are trying to minimize this error. Right? Though we don't know fx, but by training, giving different data sets, we are trying to minimizing this fx minus hx whole square summation, right? When you try to minimize this, and the best case may be, we should select an hx for which this e of hx should be minimum or ideally 0. If there is a 0, then fx is same as hx. So therefore, it cannot be 0. And therefore, there will be some error, difference. And we try to say that the difference should be minimum. That's what we are doing in all modeling of our machine learning. Whatever model you take. And this is called a generalization. What we try to say is that through this classification, we are trying to say that can it solve in a particular domain? If I give a new set of data, can it predict? More it predicts, more generalized it is. So lesser the error, more are the chances of prediction correctly. So therefore, if you try to minimize this, you are doing more generalization of the problem. So that means how generalization means what? How exactly or how correctly our hypothesized function predicts the future examples. If I give a new example which is not part of the training, how correctly it predicts its class, then I can say that more it predicts, I can say more generalized is my model is more generalized. So errors had to. This is what the whole issue is. Now, that all of you know that I have positive, negative. I'll skip this. This is how you represent. So now look at, therefore, what you see is one possibility to find most specific hypothesis, right? Sx, which could be tightest rectangle. If I take the example of the right angle, so it should be tightest. बहुत close जो मेरे positive points close हो, cover all positive examples and no negative example, which means hx is same as sx. This could be one, but the actual class fx may be larger than sx. What I am trying to say is now, keep that in mind. Let me go a little back to understand that. Hopefully this, let me take this. If I take this positive examples all in blue color, if I make a tight rectangle, fine, this may be used, but when I take a new example and try to predict, it may fall outside this tight rectangle. If I take a tight rectangle, it may fall outside this because my actual class fx is larger than that, right? It may be a possibility. If I take very large one, मैंने जो पहले बड़ा ले रखा था, if I take very big rectangle, then my actual class family cars may be smaller than that. बड़ा मैंने ले लिया. That means what I am saying is, example is, if you take a polynomial, select a polynomial of degree 4, say for example, I assume that fx is a polynomial of degree 4. But hx, I take a polynomial of degree 3, That means what will happen is some of the positive classes will fall outside this, will not be covered by this, right? And if I take a polynomial of degree 5, Hx is polynomial of degree 5, then some of the negative classes will be covered inside the model. So my fx is, if I assume that fx is a polynomial of degree 4, but if I take a hx as polynomial degree 5 or degree 3, then either some positive classes will be left out or some positive classes will be or negative classes will be covered in. So that is what we are trying to say. So thus the sum of the positive, that's what I said, thus the sum of the positive examples will not be covered by hx. That is false or negative you call. So other positive, if I take a large rectangle, covers all the positive examples and no negative examples, which means hx equal to gx, but the actual class fx may be smaller than that g, the sum of the negative examples will be covered by hx, that is false positive, right? So thus what happens in now, the actual hx that belongs to capital Hx may be between sx and gx. That's what I say, degree 4. It may be, if I take degree 3, if I take degree 5, it may be degree 4 in between that. Maybe a valid hypothesis with no error, but we don't know that. That's more example. So what we do is, keeping that in mind, that is what I say. If I say, if I take this blue one, it's a big, so some negative classes may come in. If I take this yellow one, or I take this green one, which one I should take? Right? If you look at this case here, this yellow one, it may cover some negatives here. If I take this one, it may also leave. So there is a problem. Both the cases. I have explained this. I'll not. So I'll not go in much detail of this. Let me put it. So if I take another training set, the problem is you have taken a sample of training sets. So I don't cover the whole population. मेरे पास सारा data नहीं है. I have a sample. If you take one sample, you train with one sample. You have a different Sx and different Gx. Therefore, you have different Hx. Right? A different parameter value of the. If you take different sample from the same data set, your value of optimal parameters may be different. So from a population, I can have n number of samples. Possibility, agar hum I have 1 million data, if I take a sample of 10,000, how many samples will become there? And you are training through a sample, not through the whole population. So if you train through one sample, you have one set of optimal value of parameters. You train through some other sample, you will get a different values. Right? But by and large, whatever the sample you are training, we'll assume that is the model we are using, and therefore we'll get the value of parameters for that model from that set of data. So depending on the training set X and the hypothesis class Sx, there may be several SIX and several JIX. Minimum bhi alag hoga, maximum bhi alag hoga. So that is called a set S and set G. Now, while training one by one example, we incrementally update S set and G set. On also, we assume X is large enough and there is unique Sx. What we do? Why do you say our data should be large? Data sets should be large enough. Kyun kehte hain? But we assume it, if the data set is large enough, then there is a good possibility that you may have unique Sx and Gx. Uske upar jayega bhi nahi, uske niche bhi nahi hoga. That is the possibility you try to see. And otherwise there will be multiple Sx and Gx. But with a larger data set, if the sample is large enough, very close to this, then you will get this value. That's what we assume. But now it seems very intuitive to choose Hx, small Hx that belongs to this halfway between Sx. What do you do? Now you'll understand many things with this. Keep that in mind, that we assume that, therefore we'll choose some value of small Hx which falls between Sx and Gx. If you have a large enough set, then we say that Sx and Gx are unique, that the maximum possible divider and minimum possible divider of the class we have got with a large data set. Therefore, my hypothesized function could be in between that. That's what it is. So this is to increase the margin will increase that classification, the false negative and false positive and true negative, and that kind of things will not happen. And that's what we try to increase the margin. But or it is the distance between the boundaries and the instance closest to it. That you all in SBF जब पढ़ते हैं, हमें सब देखते हैं कि भाई मेरा margin ज़्यादा होना चाहिए, so that the clear demarcation. That's all the logic is. But for error function to have a minimum at hx with maximum margin, that's the important point. The error should be minimum, that the difference between hx and fx should be minimum. But at the same time, the separation, the smaller, the sx and gx should be larger. That's what we see. Now, based on that, what we are trying to say is choose h with the largest margin. That means what? I have this g, that may be a maximum triangle, rectangle, s may be a minimum, and take h that as a big maximum difference from g as well as maximum difference from s. That's what I'm saying. Otherwise, if you take it lower, it will have maximum distance from g but minimum from s. That's what we say the margin has to. But okay, the next slide will be more important. But in some applications, if you look at the wrong decision may be very costly. So therefore, the selection of model is very important. A wrong decision may be very costly in some application. For example, a cancer patient is detected as false negative. So there is a cancer patient, but your model considers he is not or she is not. And therefore, he or she will be deprived of treatment, and therefore it may be very dangerous. So this application, a wrong decision may be very costly. Therefore, the instance between Sx and Gx can be considered a case of doubt. If anything is falling between Sx and Gx, right, we call it is a case of a doubt, and the case of a doubt will require and will reject that we have not been able to classify it, and this should be left to the human experts. In any case, whenever the case of doubt comes, that means my data value falls between Sx and Gx, then we say that this is okay. My model is not able to classify it, and therefore leave it to the judgment of the experts. Will help and save many things. So ultimately, what I'm trying to say is that as if he assumes that these models do great, but at times you must understand they are not solution to all problems, and there is still human intervention is very important. Whatever AI machine learning goes, you cannot replace the human intervention. That's the point what I'm trying to make here. Now, look at this, and that will give you many clarity on the things. Now, what I said is, you have an actual function fx which you do not know. Now you look at these three components. Actual function fx is not known. We have hypothesized a function hx will fit into that, and we have observed data x and given labels y. ये तो पता है ना आपको, जब आप ट्रेनिंग करते हैं तो आपके पास डेटा सेट और उनके क्लास लेबल होते हैं. So y is the output of the class label. Okay, ये class family है, ये नहीं है, आपने उसमें दिया हुआ है. So you know y, you know x, you know hx, but you don't know fx. That's how it is. So your error. Now your error, if you look at what you said error is in the beginning, we say fx minus hx. यही कहा था हमने. So we don't know fx, we know only y. If you know y and we know hx, therefore my error is y minus hx. Keep that. Right? So fx minus hx I am replacing by y minus hx because y is known, because my labels are known in the data set. hx I have assumed this is the model. So whatever output model gives, model मैंने चलाया hx, कोई output देगा मुझे, और जो actual output है y, उससे मैंने difference निकाला, उनको sum करता रहता हूँ और square करके. This is what we do. But this error consists of three components. Keep that in mind. Let me start in the reverse order. The last one, E inside is y minus fx whole square. What is y minus fx whole square? So fx, I don't know why I know, but do you feel that the labels which are given they are correct all the time? There is a problem, because if you look at, if I know the exact function fx, if I apply that function on the data, the output which I get may not be same as the label which I have given. Right? The label which I have given may not be same. Why? Because the data may be noisy. अगर आप एग्जैक्ट फंक्शन को नॉइजी डेटा में लगाएंगे तब भी एरर आएगी, तब भी वो गलत देगा रिजल्ट, राइट? सो व्हाट आई एज्यूम इज, since my data is noisy, therefore even if I apply the exact function fx, and the output value fx may not be the same as the labels which I have given, because labels are given on the exact value. The labels which I have given may be on noisy data. So therefore there will be a difference between the output of the actual data and the output which you have taken. So that is called noise. So the last one, the y minus fx square, represents noise, right? If you do not have a noise, then this value is 0. And even if you try to remove noise, to what extent we are able to remove the noise? There is a limit. So the last component in this error function, it denotes my noise. Now the second case is, now let me go to the first one. Expectation of x, then I said hx minus h bar x and square. When I'm trying to get an h bar x, what is h bar x? Is the mean. Why do I get mean? As I said, I may have many hx, because small hx is a member of capital hx. Capital hx is a class of, say, if I take capital hx is a class of rectangles, if I assume that my model is a rectangle, and there are many possible rectangles which can represent. So the h1x is one rectangle, h2x is another, h3x is another, hnx is another. Now, which I consider, I take an average, mean. So h bar x is the mean. So I take a mean function from this class, and therefore this is my variance. If you keep that is hx minus h bar x, it is square, it gives me the variance around the mean. You are padhte hain statistics. So the moment you say we have a variance in machine learning, what is variance? This variance is, when I select my hypothesized function, it is a mean function, and therefore the variance around this mean function is called my variance. See the difference between this is called my variance. So there is a variance. Now here, if you look at the second component, fx minus h bar x, because I have selected my function each h bar x, which I have hypothesized the optimal function or the mean function. My actual function could have been fx. So there is a difference between fx and h bar x. That's my bias. So if you look at what is bias, bias is the optimal or the mean function which I have assumed and the actual function. The difference between them is a bias. So h bar x is never an exact representation of fx. Therefore, there will always be a difference between fx and h bar x. That's what we call bias. So when you study machine learning, always you say there is a trade-off between bias and variance. And what is bias? This is what is bias is. The function which I have chosen to use is not exactly the function which has been used, and the difference between that is called my bias. Right? And what is the variance? The variance is the function, the mean function which I have chosen. The variance around that is called the deviation around that is called a variance. So if you try to, and therefore you call there is a trade-off, and there is a noise also. So my total error is my variance plus my bias plus the noise. Right? And whether I put okay. And if you look at these three functions, if I try to reduce this variance, reducing this variance means by most of the value of hx are closer to h bar x. That's why I reduce. Right? The moment I reduce this, what will happen? जो एवरेज वैल्यू में hx की ले रहा हूं और बाकी सब वैल्यूज के करीब करीब. That means what will happen is this bias will increase. Why this bias will increase? Because it may be, my function may be also a little far away. This may not be exact representation, and the closer value of around h bar x, and more closer the value of h bar x is, more is the difference between fx and h bar x. And more is the variance means the hx are far away from hx, that is cover the more classes. Therefore, it is better approximate of fx, so the bias is lesser. So therefore, there is a trade-off. The moment you try to decrease this difference, will increase because all hx are very close. So I may be leaving some classes, right? Some rectangle अगर close हो तो कुछ positive value बाहर भी जा सकते. So therefore, the bias is more. That means my h bar x is more away from the fx. और अगर hx आपके दूर rectangle थोड़ा दूर होंगे तो variance बढ़ जाएगा, लेकिन आपकी सारी positive value, ज्यादा positive value cover हो जाएंगे, तो bias कम हो जाएगा. That's what we are trying to say. Hopefully you understood this. So that's what the trade-off between the variance and bias is. And what today, before I move to the next portion, in a sense, how this applies to the NLP, is that more those who are working in the AI machine learning, they try to improve the model. How do you try to improve the model? That means the bias and the variance. I must get there is a trade-off, a balanced value of bias and variance. And that's how they try to improve both. But there is a limit to that. You cannot go point beyond. The model cannot work much better than that. But there is a trade-off. A point will come if you go to the bias, and that point everything is managed. But if you try to reduce the bias, and the variance will increase. If you try to reduce the variance, the bias will increase. Or if you try to increase the variance, the bias will. So that's how it will be. So you may have an equilibrium point there. And beyond that, you cannot improve a model. And therefore, now we call AI the data-centric AI. Data-centric AI means what? Forget what we cannot improve model beyond a point. Therefore, what you said, our data should be more clean. So I try to improve y minus fx bar, noise. The third component is noise. If you try to make improvement on this y minus fx bar, even my model may improve. The error may reduce. So the data-centric AI is trying to improve the quality of data. And the quality of data means one of the biggest factor of quality of data is the noise. So they try to make data as much as noise-free. Therefore, the error will reduce, the model will improve. So whether you focus on the first two part or the third component. So that's what new data-centric AI is. And then, okay. Hello.
Yes, sir.
Shall I take a 5-minute break?
Yes.
Before I move to the
Yes, sure.
next?
Yes, sure, sir. Sure.
Only 5 minutes, just.
Okay, sir. So, participant, we will take a short break of 5 minutes. Okay, sir.
Okay.
So this area seems interesting. I found that I observed the mathematicians working in mathematical modeling may contribute.
Yes, a lot. See, it is all done by mathematicians.
Okay.
See, the whole machine learning has come from statistical learning, and the statistical learning theory has been given by Bapnik. He talks of a lot of function approximation for this. तो 1962 के उसके पेपर हैं बैपनिक के, एंड वेरी गुड पेपर्स.
ओके.
तो वो पूरा मैथमेटिकली है, मतलब इसलिए तो कंप्यूटर साइंस वाले टच नहीं करना चाहते हैं ना.
All right. Okay.
And if one has to understand machine learning properly, one must read that. अभी तो लोग खाली they use Python library and then data Kaggle का data set ले लेते हैं और Python की library लाके लोग generally use कर रहे हैं.
Okay.
So it seems that there is no computer science in fact because कि किसी का क्या कहते हो भानुमति का क्या किसी का ईड़ा किसी का रोड़ा किसी का ईट भानुमति का कुन जोड़ा मतलब ऐसा चल रहा है. तो पब्लिक डेटा सेट किसी का है और लाइब्रेरी किसी ने बना दी.
Okay.
उसी को लोग यूज करते हैं कुछ रिजल्ट तो निकलेंगे ही एंड देन दे पब्लिश फाइन दैट इज आल्सो सम एक्सटेंट फाइन फॉर लर्निंग बट देयर इज नो कंट्रीब्यूशन एज सच बाय कंप्यूटर साइंटिस्ट इन दैट वे.
All right.
वो क्योंकि कंप्यूटर साइंस का प्रॉब्लम ये हो गया कि बेस मैथमेटिकल बेस बहुत कमजोर हो गया है. एजुकेशन में हमारा सिलेबस डिजाइन हुआ ना मतलब जैसे बाकी इंजीनियरिंग में तो मैथमेटिक्स काफी पढ़ाई जाती है, इलेक्ट्रॉनिक्स इलेक्ट्रिकल में काफी पढ़ाई जाती है, कंप्यूटर साइंस में नहीं पढ़ाई.
A huge amount of pure mathematics is used, sir.
That's what I'm saying. But
In fact, Kutniak in German, she is leader of this machine learning.
yes.
She uses pure mathematics. Absolutely, they have a chair of machine learning, foundations of machine learning. Huge amount of mathematics. In fact, pure mathematics is used there. They are doing well. What we try, we go to only shortcuts. We have libraries, we use libraries. That's it.
ये तो हो रहा है.
But they are actually doing mathematics behind this machine learning, deep learning, etc.
तो हम शुरू करें या?
Yes, sir. Sure, sir. Sure.
हमारा ऐसे कहने से कंप्यूटर साइंस वाले नाराज हो जाते हैं, हम उस सेंस में नहीं कहते.
नहीं sir, whatever computer scientist starts doing, there is a huge amount of mathematics involved.
Yes.
Whether they are accepting or not, this not matter of their acceptance.
मैं ये कह रहा हूँ कि हमारी ट्रेनिंग, मैं ट्रेनिंग की बात कर रहा हूँ ना कि हम जब पढ़ते हैं तो ट्रेनिंग कमजोर हो गई है.
Yeah, that's there. That's true.
है ना वो.
Actually, we try shortcuts ना.
अभी आप बाकी इंजीनियरिंग को देखें, सब में मैथमेटिक्स बहुत पढ़ाई जाती है.
जी.
चलिए anyway,
Okay.
हम थोड़ा एक एप्लीकेशन, let us start with this application.
Right, sir.
I'll stop 5-10 minutes before so that we have some question answer also. और जैसा कहेंगे मैं वैसा कर लूँगा.
Yes, sure, sir. As you wish. Sure.
So now let us see how the machine learning is being used in NLP. Let me make little bit of base for NLP, then I'll talk of how it is used and what are the applications. What is NLP is defined as the application of computational methods to model and extract information from human languages. That's what important. So the model, the machine learning models could also be used here for extracting information and learning purpose. Now, why it is if you look at language, maybe in written form, in a spoken form, even the gestures, sign languages are important. So I'll not go in. So therefore, the moment we deal with written languages, and sometimes we call it text analytics, and some companies work on that. And when we deal with the speech, we call it the speech analytics, or maybe sometimes it may be called also sign language analytics when you deal with the sign language. Now, to little make background, say there are around, this is what claimed, I have taken this all from the books and net, that 7,000 human languages currently in existence. And the top 10 languages represent 46% of the population of the world. So language becomes one of the important parts for translation purpose. So 46% of the world uses only top 10 languages. And English, and keep one thing in mind, and sometimes that I put it deliberately, but English language has around 1,70,000 words in its vocabulary. बहुत बड़ा 1,70,000 भी बड़ा नंबर, बट हमें ऐसा लगता है कि पता नहीं कितने होंगे, बट see, it is approximately 1,70,000 words in the English dictionary. And out of that, only what you use is only 10,000 words are commonly used in day-to-day conversation. not more than 10,000. ये मैं किस लिए कह रहा हूँ? Because this has a big role while we are doing NLP. And so that means in our lifetime, if you understand, if you know 10,000 words, maybe good enough for our day-to-day conversation. And this is the diagram I have taken from net. Probably I have forgot to put the source. So if you look at the Chinese is the vastly spoken because Chinese population is huge. And India, we have Hindi, Punjabi, and I think Bangla. 3 languages are most spoken here. Hindi is at 4th worldwide. Right. Worldwide, we have 2nd largest population, but we speak multiple languages. And the Punjabi, this is called Lohanda, that's Western Punjabi, is the 10th language in the world spoken by most of the people. So, therefore, the language becomes one important area. But keep to one of the important aspect of the human communication is that it allows reuse of shorter words. अब कितनी बार आर्टिकल लगाते हैं, कितने प्रपोजिशन लगाते हैं, it reuse of shorter words, and therefore their meaning is resolved through the context. That's what the language. You cannot in a sentence look at the word. You can say the meaning of the word is there. Therefore, the sentence has this meaning. Its meaning also depends on the previous words and the word following it. So the whole sentence, it's not. You cannot say word by word meaning. If you take, you can find the meaning of a sentence. Forget about idioms and phrases. Even a simple sentence, by getting only a meaning of a word, you cannot be always able to get the meaning of the sentence. So you must see the context. Yes, okay. Why that the reuse of shorter word is allowed more is because this reduces the computational burden on the human brain. So you don't recall too many words. I said out of 1,70,000, 10,000 are sufficient. So this burden is reduced. So you can reuse it and infer the information from the context. Now, but the difficulty with the human language they are inherently ambiguous. That means one sentence may have multiple meanings, if I put it very simple way, and therefore the exact meaning has to be understood from what you call the context. And therefore this makes it very hard for computers to process, understand. Because humans, we understand language because we know the context. Say, for example, I give a very good example right now. Say, if I put you a sentence that when I stood up in a restaurant and I see that my purse is lost. If I say this, then you will infer that I may be looking for my purse because I have to pay something in the restaurant. And therefore, if I'm paying in the restaurant, I might have eaten something in the restaurant. So this knowledge, where you get this from, you get this knowledge that I have eaten something in the restaurant, and therefore I was about to pay, and therefore I'm looking for my purse in the pocket. This is highly probable. So this is the knowledge which you have acquired from your experience from the world. And that makes you to resolve this context. So therefore you understand the whole sentence. Even I said only that when I was leaving the restaurant and saw that my purse is missing, from there you have inferred a lot of information, because the context which is not in the sentence itself. Sometimes it may be in the sentence, sometimes it may not. It is outside. So that's what called a word knowledge. So from where the computer will bring that knowledge? Can you put all this knowledge inside? No, it's not possible. And even today in NLP, we don't think of resolving carrying simple meaning. Not कि भाई आप सरकार से पॉजिटिव बोले उसका मतलब उल्टा नेगेटिव होता है. This is what sarcasm is, that you say something positive but the meaning is negative, right? So the computer will say, oh, positive meaning. So that's what the difficulties are. And so therefore the language ambiguity existed in word sense, because a sense of a word may have a difference. Like say, for example, I give an Hindi example, most of you understand Hindi, is ऐसे राम ने मोहन को काम पर जोता और राम ने बैलों को खेत में जोता. दोनों जगह जोतना है, but one has a meaning of plow, other does not have a meaning of plow, other has a meaning of putting to work. Now this jotana, if you look at, it has a meaning of plow in one context, other context it has a meaning of putting to work. Now this is the ambiguity that how do you understand that? Because you are human beings, you have a lot of knowledge. You have learned from the word and therefore you understand. But how this knowledge the computer will understand? That's what's important. And therefore, if you apply machine learning probably in the larger data set, we can acquire that knowledge and learn, and then probably do. And therefore, you have now what you call expandable or extendable AI, where you try to also see the regions. And the grammatical structures. If I go on grammars, and the structures are very ambiguous, and at times we don't know what exact structure is. And the sentence structure, that all. Therefore, the methods are required that deal with each of them. I'm not going in that detail because time, but I'll also skip this portion. But quickly, I'll say on the left side, I'll leave that in the speech. If I have a sentence, let me forget about morphology lecture, but if a sentence, there is a grammar, syntax. The grammar, if you look at the English grammar, Hindi grammar, and Sanskrit grammar, they have all, the Sanskrit grammar says, if you say, Dhavati mandam mandam, sa mandam mandam, Dhavati Dhavati, sa mandam. Whatever order you say, that it gives the same meaning. वो धीरे धीरे दौड़ता है, उसको आप दौड़ता है धीरे धीरे कह दो, या हिंदी में भी और धीरे धीरे दौड़ता है, धीरे धीरे दौड़ता है धीरे धीरे, वो जहां भी लगाओ समझ में आ जाएगा. But you know, so in Sanskrit the word order doesn't matter, but Hindi it matters at times. English is more matters. So there is a syntax, किस order में कहना है, पहला हमने वह कहना है, फिर हमने दौड़ना, फिर धीरे धीरे कहना है, फिर दौड़ना कहना है, and अंग्रेजी में पहले वो कहना है. That happened. Then the semantic, the meaning also may change. Also वहाँ भी ambiguity हो सकती है, और that also is important because from the meaning of the words you may not get the meaning of a sentence. Then discourse का मतलब है कि एक पूरा paragraph, एक sentence पे दूसरा sentence, it is a full paragraph. How do you understand the full paragraph? Because in the paragraph one sentence may have a link with the other sentence. Also, जब आप pronoun use करते हैं कि हमने कहा, आप कह रहे हैं कि भाई श्याम ने ये किया वो किया, फिर बाद में 4 सेंटेंस आता उसने, then you're referring to Shyam in the first sentence. So this becomes a discourse. How do you resolve that these pronouns, to which noun they are referring to? It becomes a big problem. And then pragmatics, that means, as I said, how to deal with that knowledge. What the restaurant वाला example दिया था, तो उसमें ये था कि pragmatics में क्या कि आपको पता पहले से कि restaurant में आप खाते और पे करते हैं, वो knowledge यूज होगी. That is called word knowledge. Pragmatics comes also. Now, leaving that aside, quickly, that I'm leaving. इसको भी मैं छोड़ दूंगा. हाँ. Okay, let me put a little bit of here. See, when you store these words, you don't need to store all words. Some words can be formed by adding. Working करना तो work में ing जोड़ दे working बन जाएगा. Worked है तो ed जोड़ने से work में. So only you have to store work and then make works, worked, and workers, whatever you want. And that's what you call stemming. You can make a word and change its form. But from lemmatization is different, where you change the part of a speech of a word also. So I'm not going in that. You can also change, because a word by adding something may become from noun to verb, verb to noun. Now, one of the issues in the NLP is tokalization, and my focus is on machine learning, so I'm quickly going through this. Say for example, a lecture is interesting. I'm not talking my lecture. Say for example, some lecture is interesting. So there are 3 tokens. The lecture is interesting. And when you go for machine learning, one of the important point is that you have to remove the stop words. Small subset of tokens occur very often. The, of, as, a, is, articles, prepositions, and say some verb like is, auxiliary verbs, that occur again and again. And if you look at learning from the examples, they may not matter. So what do? Remove them. That's what we call stop word removal at times. So for preparation of the data for machine learning, we remove the stop words, right? And one of the, it's at the Shakespeare's, if you look at the complete work of Shakespeare, Shakespeare's complete work has 8,84,000 words, tokens. लोगों ने ये भी काम कर लिया, गिन लिया सब. An important part is not only that. Why I am talking this for NLP is, out of 8,84,000, the handed words, handed tokens comprise over half of them. That means handed word ऐसे हैं जो 4,42,000 times आए, वही repeat हुए. So look at how much repetition is there. But we don't find that somebody has done this kind of work on Premchand's novel. Nobody has done, right? But they do, and that gives a very, this that how much repetition of the words is there. So though it looks big, but so the understanding the repetition makes your life easier for machine learning. That's what. So handed tokens comprise over half of them, and then baki or repeat only, but not at that much time. So what you do is that when you try to find the meaning of a word or a sentence, then what is saying that if you have a sentence, it has a word W1, WL. मुझे नीचे से ऊपर जाने दीजिए. If I say last one, that's W1, W2, WL, there are L words. So what we are saying is that what is the probability that WI, right, is any word L equal to 1 to L, comes after WI minus 1, WI minus 2, WI minus N. इतने word के बाद WI के आने की probability क्या है? That's what we see here. So that means if I have a word W2, what is the probability that W2 occur after W1? Or W3 occur after W1, W2? This is what we call n-gram models, because this will help us to understand the context of the word. So if you leave the probability that, okay, हमें ये पता है कि बहुत बार हम देखते हैं कि इस वर्ड के बाद यही वर्ड है. If you say eat के बाद हमें पता है कि सब कुछ खाने वाली चीज ही आई, right? Not something I eat table तो कोई कहेगा नहीं, something which is eatable will come. So if you find those probabilities, then when you are resolving the context, I'll select, if you have multiple, I'll select a context where the probability is high. So many models of machine learning or NLP, not machine learning, NLP especially, there's a tool called Moses, developed by, forget the name right now, Kohanen, right? Yes. And they have all these implemented. If you run that translation model, it does all these context. n-gram 5 ka chahiye, 4 word ka chahiye. If n is 5, it is 5 gram. It is n is 2. That means 5 gram means the word depends on the previous 5 words. See. And then those who are working, they know that we have a lot of ways to represent documents. And then that is called bag of words. And TF-ID, that is what you call is text frequency identification, something I forgot in the form. That means एक text में कौन सा word कितना frequently आ रहा है, या reverse that एक word कितने text में आ रहा है. We count all those. Therefore, this gives us an idea that what is the probability that a word occurs how many times. What is the probability of occurrence of a word, and so on. So this will help us to make matrices if you are using CNN say for this. So हमें तो देखना पड़ेगा ना एक word किसकी context में कितना आ रहा है. If I make a matrix of all words in a language, मैंने शेक्सपियर के 1,70,000 वर्ड का मैं उनको मैं रो में भी ले लूं, कॉलम में भी ले लूं, then I can say that रो में एक वर्ड लिया, उसके context, उसके बाद कौन-कौन से आ रहे हैं, उनकी probability कितने, सबका मैं value लिखता जाऊं. So I will always have a matrix that which word comes in the context of which word and what is its probability in that table. But that I have to make a program and count. There are programs for that. Okay. Rather than going on these details of NLP, let me put few things because okay, हम अंग्रेजी में केवल 9 part of speech पढ़ते हैं, but there are multiple other languages में more part of speech. So the approach is कि हमारा rule based approach and statistical approach. रूल बेस्ड अप्रोच में ये है कि भाई वी मेक सम रूल्स टू identify the meaning of a sentence. And statistical approach, we don't need to know the rules, the grammar rules or something. What we have data, which is called a corpus. And from that data, we try to identify the pattern. And this has been extended for machine learning. So what we are trying to understand is that we'll work on corpus-based data. And Indian languages especially are very, we call these are low resource languages. We don't have much data available digitally, simple, or we don't have much data which is in the required form as well. That's one. So parsing I leave. Okay. And there are many things that we have a word net where we have synonyms, antonyms, and everything is kept. This word it's synonym, hyponyms, hypernymy. All these are, that means all these are kept there. And then one question comes in NLP: how do you identify the names? Right? When you say the Washington DC, whether you are referring to a person or a place, how do you identify those? So I'm not going in that detail right now. Then relation extraction. That means I say that Laura Bush. If I say that means I'm referring to the wife of George Bush. How do I identify that relation? And then semantic roles means every word plays a role. Some plays the verb plays a role of an action, and some noun may be an instrument, some noun may be an agent, so on and so forth. All these has to be. Now the important part here is, leave me this aside for the thing. When you are dealing with the NLP, with the machine learning, just a minute. Okay. Now, how do you represent the words? The sentence, simple sentences may not be useful as well. So there is a what you call a vector space model. As I said that if you have a document, you are making a vector space, then you say put that all in a vector and then say whether that word is there or not. If I have all words of a language, मैं language के सारे words को ले लूं, उनके order में रख दूं 1, 2, 3, and in a document whether that word occurs, if I'll put 1, if that word does not occur in the document, 0. So what I'm making a vector of all words. If that word occurs in a document, then I'll say 1. If does not occur, 0. So I have a vector of 0 ones. It will be a large vector. But you see that what you'll find is many of the words does not occur, therefore there is a 0 value. And the dimension is huge because the language, the words may be large. So the dimension is huge. What I felt is many of them are not useful. And that is what's called the curse of dimensionality. That means it will take unnecessary processing time. And second is I make a co-occurrence. I make a matrix rather than a simple vector. And then I say, किसके साथ में कौन सा word आ रहा है तो 1, नहीं आ रहा तो 0. So that's what we can see co-occurrence. That will be useful. If I'm using CNN, you need to use some matrices also. And that will also give a representation in terms of numbers. So one of the problem of NLP is text classification, where we can use machine learning. The goal of text classification is to assign in document to one or more categories. So if I give you a document, then you say that which category this document belongs to. I say whether it is related with, if you say that the category is, whether it takes subject category, anything, psychology or geography, then I set up document which it is a film related or it is something else. You may have multiple class. So this is one. So that means if I given a text, I have to identify which class it belongs to. Right? It is history document hai, ya history ancient ka uska hai. So I have multiple classifications. So one of the important application of machine learning in NLP is the text classification. if I give a text, I say, okay, ये किस history का है, किस subject का, that's what I'm saying. So what I do, I have large data and train my model, and that model has trained to based on the sentences and the data it has identified. So it is one of the core tasks in many of the NLP applications, which will be helpful in information retrieval. और अगर आपको कोई अगर गूगल सर्च कर रहे हैं, फिर एक क्वेरी दिया है, तो अभी तो गूगल सर्च क्या करता है, हमारा सारा लिंक हाइपर लिंक या डेटा से लाता है. बट इफ आई हैव क्लासिफाइड डॉक्यूमेंट and depending on the query, we will only look for those documents which have been classified. The text, where the text has been classified, it will look only for those. And it may be useful in spam detection also, because to which class this text belongs to, and then what. And sentiment analysis also is one of the key area of research, where you said that generally people talk three sentiments: positive, negative, and neutral. कि भाई ये सेंटेंस का वो पॉजिटिव सेंस में कहा, नेगेटिव सेंस में कहा कि ये. बट इन एडिशन टू दैट देयर मे बी अदर देन ओपिनियन, देयर मे बी इमोशंस आल्सो. ये गुस्से में कहा, खुशी में कहा. सो अदर काइंड ऑफ सेंटिमेंट्स व्हिच मे बी इमोशंस अदर देन ओपिनियंस. एंड देन ओपिनियंस आर इंपॉर्टेंट इन द मार्केटिंग स्ट्रेटजी, बिकॉज जब सामान बेचते हैं तो उनको लगता है लोगों का ओपिनियन लेते क्या चाहिए, एंड द मार्केटिंग दे सेल दैट. सो वन ऑफ द, दैट्स व्हाई द सेंटिमेंट एनालिसिस is very important, because you try to analyze the sentiments of a customer while buying something. And that's what in the store, you collect the data, analyze through machine learning, classify that, and then see that what kind of products are selling more and what kind of sentiments are people are swaying against some products. That's what the marketing strategy is being done. So here you can apply machine learning techniques for classification. You can use supervised learning, fine. Then the question comes how to represent the documents, which features are to be selected, and that's what all you have to do. I'll skip this. So the common method, use of bag of word I talked about, is that n-gram frequency or term frequency, inverse document frequency, sorry, TF is term frequency and inverse document frequency. Vectors and label them category wise X. So these could be the techniques which are used. Without going in details, I'll talk simply now. And the techniques which are applied right now are the KNN, SVM, decision tree, logistic, and name-based. They are the most applied techniques for text classification right now. But the results are not very well. You can see other techniques on that also. The text classification, CNN may be more useful. The reason is that the CNNs are able to capture temporal and hierarchical features in the variable length text. These other models are not able to capture the hierarchical features. CNN has that capability. That's what you see. And the words and characters embedded is generally, see, what happens is you have a sentence के अंदर what can the correct. If you look at, there is a first hierarchy. So therefore CNN could be useful. And since there are more complex features, sometimes deep CNN may be more useful to learn the complex features of those texts also. So they're very useful, and people must try. And it's not that people are not trying, but could be more useful. And the RNN, if you look at recurrent neural network, as I said, the most techniques now used is a neural network based on. And RNN becomes useful for text and classification because RNN has a capability to capture the context in a sequence. And the word in the sentence, as I said, in the sequence, one word depends on the other word. The previous one may also be a future word. So therefore, RNN may be very useful in the sense of capturing the context in the text. So what you can have deep RNN also. That's why encoders and decoders are more used for NLP applications. Even Google for translation uses BERT, bidirectional encoder transformer. Yes, that's what the recurrent transformer. Correct, BERT, B-E-R-T. So once the entire sequence is encoded, the last hidden state used to protect the class. That is what happens. But the important part is the RNN captures the sequence, but the limitation of RNN is also that since it will depend on the input, and if input the variable length, then the number of layers may depend on the input. If the input is a variable length, how can you vary the layers? So therefore, you have to fix it and then see how to do. But RNN could be more useful. That's what BERT and LSTMs are used more with the NLP applications. As I said, other application area is your sentiment analysis. That fake news detection now talks about whether the news is fake or not. So what kind of sentiments it refers. So there are subjectivity and objectivity. If you look at opinion is a subjective and emotion is objective. So whether you are doing emotion analysis or opinion analysis, so both are sentiments. That's what you can also the valence is किस intensity से किसी बात को कह रहे हैं and कौन सा emotion dominance है, that all can be measured if you use, and that can be useful in sentiment. Entailment analysis is this is an open research area, not many people work. A logical concept in its truth is one fragment leads to truth another fragment. That means, can I have a antecedent and precedent relationship? That is, from one sequence I can find out whether when I talk of Laura Bush and then George Bush, can I infer that yes, one is husband or his wife? So that's what I can infer on. One precedent is George Bush is this and Laura Bush did this. Can I infer that one is inferred from the previous one? Entailment, that is an open area, not much work is done. Topic modeling is also another area where we try to identify that which topic it belongs to. I said there is a difference between text classification. I have given a text, I say that it is history ka hai, kiska hai. And then you can more of I say kis topic par hai. So they are more closely related, but still people keep them little differently. But I think they are very closely related. But important is that can I summarize the text? Summarize large collection of text. That is what the topic modeling provides an ability. You have a big news, and then can the news be automatically summarized? The text summarization, if you look at, is another area. I'll not go this right. So the CNN framework is better for this also. The same logic here. So important area of NLP is machine translation, because we need to translate document across one language to another automatically. That's important point. Others may be multiple areas, but large focus of NLP using machine learning is a neural machine translation nowadays. The problem with the machine translation is that we try to translate a source language to target language. What we find is one of the important goal is the faithfulness. That means, does the translation preserve the meaning? And if you go on the speech, that it preserve the natural sounding. So faithfulness is on text and fluency is on speech. So our focus is on text. So multiple techniques. First, direct word translation. एक word को दूसरे में बदल दो, but it doesn't carry the proper meaning. Then एक phrase को बदलो. Then the important translation scheme came when the statistical translation came in. It has what you call is word alignment. We align the words so that in one language and other language, so this is equivalent to this. Therefore, we are able to translate. Why word alignment? Because there are 2 words in language may be equivalent to 3 words in another language. So the alignment will say that there are 2 words here equivalent to 3 words there. So and so. So PE is a language model. Let us see what we say is H, the probability of a sentence translated in H, if it was in equivalent in English E, then I'm translating Hindi. What is the probability that a sentence has this translation? If I say flying planes are dangerous, if I have to translate it, this is English. Flying planes are dangerous. तो हिंदी में 2 possible, मैं उसको कर रहा हूँ. एक कह रहा है कि प्लेन उड़ाना जो है खतरनाक है, एक कला जो प्लेन उड़ रहे हैं वो खतरनाक है. It can have both meaning, and therefore there's ambiguity. But in my translation will give me more options. Both the options is said प्लेन उड़ाना, जहाज उड़ाना खतरनाक है और उड़ते हुए जहाज खतरनाक. अब what I am saying is now the plane उड़ाना is, what is the probability that plane उड़ाना खतरनाक है if given the flying planes are dangerous. दूसरा है कि उड़ते हुए प्लेन खतरनाक है given that the flying planes are dangerous. दोनों की अलग अलग probability होगी. I will select the sentence which has higher probability. That's what the whole translation scheme is. The approaches which are applied in machine translation are CNN also, and with the gating is important because you influence the target word. The CNN with the attention mechanism is another LSTM with attention people have been working, but CNN with attention could also be very useful for past performance of machine translation. But machine translation, that's what has its natural fit for RNN, because RNN captures the context, as we said. Because the sentence may differ in length and order from the desired output, but early neural machine translation relied on the recurrent encoder-decoder architecture. That's what the large language models nowadays use. Large language models, they talk of encoders and decoders. So input X in a vector, so we have to represent the input sentence in vector form, and then use your RNN. So there are also some tools for evaluating the machine translation you do using NLP or whatever. What is the measure? There are tools through which you can measure the performance of the translation is, how correct the translation is. One of the most important is called a BLUE, which is bilingual evaluation understanding. It gives you a score between 0 and 1. Because when you translate a sentence automatically, that sentence has to be compared with the human translated sentence. Sahi hai ki nahi when you do validation. And in that case, how close the translated sentence is to the human translated sentence. And that's what gives me a score between 0 and 1. And that we call a BLUE score, bilingual evaluation study. So this is a quite quality evaluation matrix for MT. And that's how it is used. There are other systems. I think many question answering systems can be designed. And automatic text summarization, when people do, they are extraction based and abstraction based. Extraction based is people choose the keyword and then say this is the summary. That's not very useful as per machine learning. But can you find the abstract meaning of the text and summarize it? That's where machine learning is used. So CNN with the max pooling gives you the clear advantages capturing local and global information. And also the hierarchy or the word embedding, as I said, could be very useful in summarization. It may be difficult to get that quickly, but still, let me summarize rather than, okay, let me put some tools here that may be useful rather than talking all theory. Generally, people use the software libraries for this. So Python, if you look at the Keras high-level deep learning API written in Python are very common interface various people use for deep learning, TensorFlow. And TensorFlow is other popular source of machine learning and deep learning libraries. And the Panda library is used for implementing data structures. And the SCI kit, open source machine language algorithm and evaluation. And Matplot for visualization is an open source tool. And I think that NLTK is a very important tool for natural language. It is called Natural Language Toolkit, provided by Stanford University, and the popular open source toolkit for NLP and text analytics, where you can, jitna bhi aapko ye part of speech identify karne hai, tagging karni hai, and you have to also do n-gram models. You can many tools. SPSI fast open NLP library written in Python for post of tagging and named entity identification. And GenSim library, open source library for vector space modeling. If you have to convert the text into the vector space, and then you should use GenSim library. So what with the ultimate, what we are saying is that the neural machine translation is one of the most significant applications today. A lot of work being done, and people can participate, and large language models are useful. And a lot of work has to be done on Indian languages. That because the earlier work has been done on rule-based and example-based, all these, but NMT-based work is not yet that much. The huge efforts are still needed because Indian languages do not have corpora. We don't have corpora. Is you give it may be a well-validated set of sentences from a language or a domain. We lack in that, but yes, CDEC provides some, others may also provide, but still we need to develop large corpora for if you want to use machine learning for this. But nobody is yet has used reinforcement learning for NLP. That's an open area still. That's fine. I think these slides I made. I have studied a book called Deep Learning for NLP and Speech Recognition by Uday Kamath and John Liu and James Springer, 2009 the book came. I studied this book during COVID, and based on that I prepared my slides myself. That's what the reference I give. And I must recognize this book and thank the authors for writing such a beautiful book to understand. Thank you. I think I should stop here. Any question? I'll take questions then.
Questions, please, participants. Sir, Dr. Gaurav Kumar is asking, what are the emerging research topics in natural language processing?
See, there are multiple topics. What I said is large number of people are working on sentiment analysis. If you especially look at Indian data, because this can be used for identifying the terrorist activities as well. And the fake news on the social media is one of the very crucial. How to identify fake news on the social media, so that if you are able to identify, then the such users can be stopped. And now the question is, but we should not, how accurate your analysis is. That is important, because no user should be, by misleading users to stop that. And the largest area is the machine translation, where people use on large language models for translation across the languages. And the reason being is, if you look at Indian language itself, I'm telling very frankly that even if you have the research, if you do creating corpora data sets in NLP, it's a big contribution now, because we don't find data, and data find in few domains for something, but it may not be very useful. So creation of data itself is a big and if anybody working in this area, half the efforts goes in creation of data. And then therefore then if you look at machine translation and optical character recognition, still are very key areas, but not all languages we get optical character recognition also. We may have some in Bangla, because somebody worked in that. And if you look at Indian languages, we have how many languages across the country? And can you have a system where you can have automatic translation system for across these languages? It needs huge efforts. Government has given a lot of funds for that area, the Ministry of Information Technology, but still we don't have very fruitful results. Google does many things. If you look at and look at the quality of the Google translation, but can you do some improvement on that? Look at, as I said, Google use BERT translation system, but can you do some improvement so that the quality of the translation improves itself? One is creation of huge data. but other is the quality of improvement of the model itself. So I said text, all areas which I have mentioned is that all areas are open areas. Text summarization, sentiment analysis, topic, text classification, machine translation. And if you go little interesting, but nobody talks of translating poetry is a very difficult one. And nobody, very few, rarely will find people touching that in a translation of a poetry. But it needs a lot of, different kind of thinking. It may need huge effort. If somebody is really interested in doing a long-term research, probably look into those areas, translation of poems. Would be a very great effort, and then may have to contribute something technically, not only the using tools. Because these simple tools may not work at times, because machine learning techniques may not be, so can you find the emotions expressed in the poem? Then only will be translated to right emotions, right? So the machine translation will require a lot of capturing of the emotion rather than simple meaning of a word in the poems. Would be a great area to work.
Sir, another question from Vijay Jariwala is he's asking, will it be useful for plagiarism for local languages? Though it's not clear to me.
Yes, yes, very true. See, now if you look at the most of the plagiarism tools, if you look at Turnitin, they are not very well to capture the paraphrasing, right? It will say how many words are matching, says limit 6 words, 8 words are matching in a sentence, this is plagiarism. But it does not, so people using paraphrasing tools, वो उसी idea को अपने भाषा में बदल के लिख देते हैं. So can we have a tool which also identify paraphrasing? That could be a great area to work on NLP. So I take a sentence, even if it, so if I capture I said text summarization abstract based. What does abstract based text summarization does it? You have to identify the sense of a text and summarize in small words. If you are able to do that, similarly, if you get the sense of a text, and then you can say, you may write in other words, using other language paraphrasing, then still you can say the same idea comes from there, it has been paraphrased. So the plagiarism tools for paraphrasing is a very key, very important area, and one should work on that.
Any further questions? So in case no questions, let's thank Professor Lobiyal for enlightening us on machine learning for natural language processing. Thank you so much, sir.
Thank you.
Organizers, please take over the proceedings.
Yeah. Thank you so much, sir. Thank you, Lobiyal sir, for accepting this our invitation for this lecture. And I know you are having a lot of many assignments, many duties, and you are busy with this. But even then, you have accepted our invitation and graced us with this great knowledge. So thank you, sir. Thank you so much, sir. And thank you. Yeah, sir. Yes.
See, मैं बहुत दिनों बाद Zoom चला नहीं था सुबह, because a lot of people all work on Google Meet. आजकल सब Google Meet पर कर रहे हैं ना. जी. So we have been using Google Meet. So Zoom बहुत दिन से चला ही नहीं था, but password बदलना पड़ा. It took some time.
जी sir, जी.
Anyway,
yes.
Thank you for inviting and giving this opportunity to interact with.
No, sir. We are really blessed, sir. Thank you so much, sir. Thank you. Thank you, Dr. Professor Atul Gaur, sir. Thank you so much for your today's session chair, and we are really thankful for your presence in today's lecture. And this is, sir, a kind of, sir, token of love and our respect towards your contribution. Thank you so much, sir.
Thank you. Thank you very much.
Yes, thank you, sir.
So shall I leave now?
Yes, sir. Yes, sir. Please, sir. Thank you so much. Thank you, sir. Yeah, Professor Gaur, thank you so much for your today's presence in this lecture, and you have given a lot of time to us out of your busy schedule. So thank you so much for that. and we will be in our connection. You are always, whenever we ask, you are always given time. So thank you for that. And
Thank you, sir. Thank you. Anything, anytime,
Dr.
sir.
Yeah, thank you so much. Dr. Meher Chand, sir, are you there, sir?
Yes, sir, I am here.
So over to you, sir.
Thank you, dear Dr. Deep Singh, to handle the session, and Dr. Atul Gaur, sir. Good morning. I first met you on virtual mode, and this session was really very wonderful and interactive, informative for all the audience. Dear participant, the recording of the session will be available there and will be uploaded on your playlist, as well as the feedback form will be shared in the WhatsApp group. So you need to submit. The questionnaire quiz has been sent to all the participants, and I hope that you have submitted the same. Tomorrow we will start the session at the same time. So it is now over the session. Thank you to all of you to being the part of this faculty development program. Thank you very much.
Thank you, Professor. Thank you.